Okay, so what we want to be able to do from this lesson is just to understand the difference between vectors and scalars. Okay, if we can understand the difference between a vector quantity and a scalar quantity, and then just name some of the vectors and scalars that we would use in forces in motion. Okay, so in physics we've got two main types of quantities that we will use very, very regularly. So it's important for us to understand the difference between them. We've got scalar quantities and we've got vector quantities. And I've got a nice little video here of Gru from the first Despicable Me movie. And of course, in that movie, there's a little character. The bad guy's name is Vector. Okay, so please have a look at that. So, just to summarize, a scalar quantity is something that only has size or magnitude. Okay, magnitude is another word for size. So, a couple of examples of that are mass, time, energy. Okay. A vector quantity, on the other hand, has got both magnitude and direction. So a vector quantity contains a little bit more information than a scalar quantity. And a couple of examples there are force, acceleration, velocity, and displacement. Now, what I often like to say is that some scalar quantities have what I call vector cousins. Okay, so I've got a table just here. And the first thing on the table is the quantity length. So length, or sometimes it's called distance, or height, or width, or something like that, can have a couple of different symbols. If you're calling it distance, you'd probably use the symbol D. Length, you might use L, width, W, H, height. Either way, is they're all measured in meters. The symbol is M, lowercase m, and just an example of 5.2 meters. Displacement, on the other hand, is what I would call the vector cousin of distance. Okay, so it's the vector cousin. In other words, it's kind of a distance with a direction. So we give it a different letter, and sometimes you'll see it as delta x, but in GCSE we would use the letter S for displacement. And sometimes you'll see it written as delta S, like this little triangle. Okay, triangle just means change in. Okay, so change in position or change in distance, if you like. Okay. Again, notice we use the same unit as we would have done for distance or length, and again the same symbol, but the difference here that this one has got a direction attached to it. Similarly, we've got a scalar quantity. Speed. Speed just tells us how fast something is going in meters per second, m/s. But we've also got its vector cousin, which is velocity. And velocity is denoted by the letter V. And usually vectors are typed in textbooks with a bold face. Okay, so if you notice the type here is bold, whereas back here it's not bold. Notice it's the same unit, but this one has a direction attached to it. So what that does is just kind of pins down the location. Because if I was to say to you, well, you got to go 32 meters per second, well, 32 meters per second could be in any direction. So if you're starting from here, you could go 32 meters per second in any given direction all the way around. So you've got a huge, huge circumference that you could actually wind up at. Or if you were to drive 100 kilometers per hour, for example, then you'd be doing 100 kilometers per hour. It could be anywhere within that circle. But if I say to you that you've got to drive exactly 100 kilometers per hour due west, okay? Well, then you start here and you go west only, okay? So that pins down the exact location because it contains just a little bit more information than just the speed. Similarly, acceleration is also a vector quantity. Notice this one will have a unit of meters per second squared, and of course we'll come to that later on. This will be 10 meters per second squared down. We'll see later on that that's acceleration due to gravity. Force is another common vector quantity, especially one that we would use in forces in motion. It's got the unit, the Newton. We use the uppercase N to denote as its unit in the calculation. And the force will be, say, 40 newtons left or 40 newtons right. Again, it gives us the exact direction. A couple of other scalar quantities that we would already be familiar with are time. So time is a scalar, doesn't have direction. Mass is also a scalar, does not have direction. And energy. Energy is an interesting one, and we'll come to that later on during the year. And that unit for energy is the joule. Okay? So hopefully that makes a bit of sense.